I am Anil Kumar. Welcome to my series on transformation of functions. This is a prerequisite for calculus. In this test paper, I am going to share with you 7 very interesting questions. First, I would like you to just make a note of these questions. Then you can solve and then watch my videos. So I hope you can see the first two. Here is the third question where you have to write the equation of the graph given to you, which is a transform function where there could be horizontal stretch or a vertical stretch. Question number 4, we need to graph the transform function from the given function. Question number 5 is a very interesting question where we are given domain and range and we need to find its transformed domain range where the transformation is provided. And question number 6 is to find the x-intercepts in the new image function whose transformation is again given to you. And question number 7 is that a square root function, which is a transform function, has been reflected on x equals to 4, and you have to write the equation of the reflected function. A graph of this kind will really help you to get the answer, so it will be better to first sketch the graph and then find the equation, right? So I hope you find them interesting and useful. Let's begin with the solution of the very first now. The first question here is that the domain of a function is from -2 to 4, both included. What is the domain of g of x? Where we are given that g of x is equal to minus f of. So when you are given a function like this, you should always factor the coefficient of x, which in this case is 2 minus 2. So it becomes x and that becomes minus half, right? And then we have minus 3. Now if that is the transformation, then any coordinate point which is x and y on the original function will now get transformed. The x values will be divided by minus 2. So we have minus x by 2. And that means you have to add half, right? Then you have to add half, translated half unit to the right. The y coordinate values will get multiplied by the negative value. And then you will do negative 3. So that is how the coordinates will change. Now we are going to apply this on 2 and 4, right? So the x value is 2 for you and the y value, rather minus 2 I should say. It is minus 2, not 2, and 4. Now if I do this, minus 2 for x. So minus, let me write minus of minus 2 over 2. Plus half, that becomes the x value. The y value will be minus 4 minus 3, correct? So that is what it will be. So let's simplify and write down. So this is plus 2 and 2 cancel. So we have this as, let's do it in 2 steps. So minus and minus becomes plus 2. 2 over 2 is 1. So we get 1.5, 1 plus half. And this is minus 7, right? So minus 7. So that becomes the answer for this particular question, right? So we have our answer, which is 1.5 and minus 7. Question number 2 is, write the image function after the following transformation of reciprocal function. So basically, you are given the function as 1 over x, and those are the transformations which you have to do. So the very first one here is reflection in the y-axis. So when I say reflection in the y-axis, then it means that that's a vertical reflection, correct? Kind of like this. So that means the x value becomes negative, right? Then we have horizontal stretch by a factor of 7. So stretch, so that means this will be multiplied by 1 over 7. Shift right by 3 units and shift up by 2 units. Well, so that means the transfer function should be all horizontal nothing vertical except for shift of +2, right? Shift up. So let's look into these horizontal part, which is reflect on y-axis, horizontal stretch by a factor of -7, and shifting right by 3. So these three are all horizontal. So with that in mind, we could write our function as 1 over. So everything is happening here, right? So it is -1/7 times, as far as x is concerned, shift 3 units right. X minus 3. Is that clear to you? Now that is very important. Include this reflection on y-axis in the denominator. And then now let's take care of the shift by 2 units up. That means +2. Is that clear to you? So that becomes your solution for question number 2. Now let's take question number 3, which is you need to state the equation of the given graph. Now clearly this is an absolute function where the vertex has gone to 5 and 7. Now the points which are being shown here, when you move 1 unit to the right, instead of moving 1 down, you're moving 2 down. Do you see that? So from the graph, it seems that there is a translation of, so there is a translation. So the translation is you're going x 5 units and 7 up, right? So that is the translation. And 7 up. Normally, when you have this absolute function, it will be going like this, correct? It will be like this. So there is a reflection also. So I'm writing in the reverse order. And then you see it is first reflected, of course, and there is a reflection on x-axis. And apart from that, there is a vertical stretch. Since it has become narrower, right? So there is a stretch, and that is a vertical stretch by a factor of 2. So those are the things which you observe here. And therefore, you can write this function as y equals to, since it has been vertically reflected, minus for that reflection. We'll first write the vertical stretch, which is a factor of 2, right? And the translation, horizontal will get inside, which is x move 5 units to the right, so -5, and 7 units up. So we got +7, correct? So that is how you could actually write this particular equation of the transformed function, correct? So I hope you can see the graph very clearly. It is this absolute function we are talking about. Correct? Now the second graph here is square root function graph, which has been reflected. Correct. So normally the square root function graph will start from here, and at 1 you expect 1, right? So basically the square root function was like this. 1, 2, 3, 4. 4 it was 2, right? So something like this was the square root function. This is square root function. But it has been reflected, and this reflection is as if it has gone downwards. Do you see that? So it matches with reflection on the x-axis. That is one thing. Second, it has been translated clearly to this point. But more than that, what we also see is a horizontal stretch. So in this case, we have horizontal stretch. Instead of 1 unit away, this point, which is 1 down, is 2 units away, right? So basically what you observe here is reflection on x-axis, so vertically reflected, and then there is a horizontal stretch by a factor of 2, and translation. This is the proper order to write transformations. Translation is minus 8, 4. That is the translation, right? So 8 left, 4 up. So we know these are the three transformations which have taken place. And based on this, we can write down our equation. That equation should be y. Reflection on the x-axis means negative for sure. We are not assuming any vertical stretch, so leave that. Horizontally stretched by a factor of 2, that means half, right? And then translate it 8 units to left, that means plus 8, and 4 units up, plus 4, correct? So that gives you the equation of this particular square root function which has been transformed. Right? Now let's move on and take question number 4. So let me highlight this diagram, which is a set of straight lines. So that's the graph. Since it is very light, I've also written the coordinate points for you. Okay, so those are the points which you need to consider. And the graph of transfer functions is required. So we are given y equals to minus f of, again factor 2, x minus 5 plus 1. So there is a reflection here. So in general, any point which is xy will be now transformed to x values will become half, and then to them you have to add 5. So this is what happens to x value. For the y values, they'll become negative, and then to them you have to add 1. So that is the shift in the coordinate points. So now let's begin with our coordinate points A, B, C, D. Let's call them A, B, C, D, and E, correct? So let's write these coordinate points here. A is what for us? A is minus 5, minus 1. B is minus 2, 5. C is minus 1, 3. D is 2, 3. And E is 6, minus 2. So these are the points. Let's see how their values will change. Half of this value is minus 2.5, and then when you add this, you get plus 2.5. So this changes to A dash, which will be 2.5. The y value will be negative this plus 1, that means 2. Now this image will be, half of this is minus 1, minus 1 plus 5 is 4, and minus 5 plus 1 is also 4. Now C dash will be minus half, that means 4.5, and 3 minus 3 plus 1 is minus 2. Now here D, image will be, half of 2 is 1, 1 plus 5 is 6, 3 minus 3 plus 1 is minus 2. As far as E image is concerned, 6 half is 3, so we get 8 here, and minus becomes 2 plus 1, 3. So those are your new points, right? So just plot these new points and sketch the graph. So A is 2.52. So it comes on this side, makes sense, since we are reflecting, and then we are moving like this. Okay, so 2.52, so 2, 2.5, and 2. So it comes here. So that is your A dash. B is 4, 4. This point B is wrongly calculated. When we do minus of 5 and then add 1, we get minus 4 and not plus 4. And that was creating a problem. So B dash will basically be at 4 minus 4, right? So it will be at 4 and minus 4. So B will be right there. So now we get a reflected image, as you can see. And the point will be absolute. So that is not the right point, correct? So that is how we are going to get our function. So let's join our points. First, we'll connect this A dash with B. B dash, right? That is the point. And then we have this function here. Horizontal which has been horizontally compressed also, and then this portion, which is, now that should have gone up. So let's calculate the last point also clearly. So minus 6 half is 3. 3 plus 5 is 8. Minus 2 becomes 2 plus 1 as 3. So this point is 8, 3. So at 8 we'll get 3. So here is 8 and 1, 2, 3. That becomes 8 and 3. So we are going to connect this point, correct? So that is how we are going to get our function. Let's write these image points, which are A dash. Here we have B dash, C dash, D dash, and E dash. Correct? This has to be reflected on the other side. And then move right. So that will be the transformation of the given graph. So I hope these steps are absolutely clear. Now let's move on and take question number 5. Given y equals to f of x and domain is x belongs to real number where x is less than or equal to 15, range y belongs to real number, y is between minus 20 and 8, find the domain and range of this particular function. So let me rewrite this function after factoring. So we have y equals to minus 0.25 is 1 over 4. F of minus 3 is a common factor. X minus 9. 27 divided by minus 3. And we have plus 6. Now, in this case, we are talking about domain and range. So this part here will affect the domain, right? This part will affect the domain. So let's look into domain first. As far as the domain is concerned, to the points given, we need to apply this transformation. So which is minus x over 3. You have to divide by this 3. And then you have to add 9. You have to add 9 to it. So that is what happens to domain. We are looking into x less than or equal to minus 15. Now when you say x is less than or equal to minus 15, when you multiply by negative value, negative 1/3, the sign changes. Do you see that? So what we have here is x is less than or equal to 15. Now when I do minus of this and then divide by minus 3, in that case it becomes greater than minus 15. Do you understand? So it becomes, so when I do this portion here, then we get x, let me write in a different ink, that is what is given to us. But when we do this transformation, then becomes greater than equal to, this divided by minus 3 will be minus 5 plus 9. So that is, x will be greater than equal to 4. Is that clear to you? So whenever you divide or multiply by a negative number, inequality changes, and that is very important to consider. Correct? And now let's look into the range. So as far as the range is concerned, we are going to multiply the y values by 1/4 negative, right? So whatever is the y value, we'll multiply that by negative 1 over 4 and add 6, right? So what we have here is, we could do it like this also. We have x, y, which is like this, correct? Minus 20. Now we want to multiply by negative 1 over 4 and then add 6. So when you do 1/4 negative, this becomes 5. Positive, right? And then the sign changes. Do you see that? And here we do get negative 1/4 of the y. The sign will change. And when you divide this by 4, you get 2 with a negative sign. That is the first step. And now we are going to add 6. So in our transform functions, we are going to add 6. So 5 plus 6 is 11, right? So 11. And that will be minus 1 by 4y plus 6. And that will be, when you add 6, it will become plus 4. So now it is between 11 and 4, correct? And now we are going to write down the range, and the range will be, you can now write range as y belongs to real numbers, where y is between greater than equal to 4 and less than equal to 11. Does it make sense to you? So that is how you are going to find the range, right? Do you understand? So in inequalities, whenever you multiply by a negative number, the sign changes. You have to keep that in mind. Okay. Now let's take question number 6, which is a quadratic function has this equation. Determine the coordinates of x-intercepts of the image function. Okay. So we have x-intercepts at which points? -7 and 5. So let's say -7, 0, and the other one is at 5, 0. So those are the x-intercepts in the function. Now the transform function for us is, we are given this, let's rewrite this, y equals to -1/4 of the y value, right? -1/4 x plus 3. Now it's important to note that there is no translation up and down. Therefore, the y values will be zeros, right? Okay. So the transformation clearly indicates that any point xy will now be translated. The x values will get multiplied by -4 times and then take away 3. The y values will get multiplied by -1/5, the original value. So the point 70, which is one of our x-intercepts, will now get moved, and this will get multiplied by -4, that means 28, and taking away 28 and 3 from 28, we get 25, right? Here anything times 0 will be 0 as expected, and for 5 and 0, 5 times 4 will be 20. Taking away 3 from 20, this is -20, right? So -20 and taking away 3 will be -23, and that value will be 0, right? So here in our case, answer is the new, I should say, image x-intercepts will be at 25 and -23. Is that clear to you, right? So that is how this question will be solved. We're absolutely clear about how to work with inequalities when we are multiplying with negative numbers. The sign changes, right? Now let's take up the last thinking and application question, which says, given f of x equals to -square root of 4x minus 12 plus 5, the g of x, which is graph of f of x reflected along the line x equals to 4. Sketch the graph of g of x and find the equation of g of x. So let's first understand the given function itself, which is a transformed square root function. Taking 4 common, we get x minus 3 plus 5, correct? So what I will do here is construct a rough sketch here. Okay. So let's do a light sketch. So this is a square root function which has been reflected. So it has been reflected and has been moved to 0.35 and vertically stretched. So I will just say that let this be the 0.35, right? Let this be 0.3 and 5. And since it has earlier it was like this, right? So now it is like this, correct? So not like that, but earlier it was like this. It has been reflected in this fashion, reflected along the x-axis, and then moved to this position 3 and 5. So this graph will be kind of like this and vertically straight, right? That is how it is going to be the function f of x. Now, if I am going to get the graph of g of x, which is reflection on the line x equals to 4. Now this point here is 3. Let us assume somewhere in between is 4, right? So let's say this is my line, which is x equals to 4, correct? So if I am reflecting this on this particular line, which is x equals to 4, the point here will get reflected to this point. Do you get the idea? And somehow this graph will be shown like this. So I'm not making any scale at present, but I'm just showing you how to get the equation. So this point here will be y value remaining same, but the x value will be 1 unit away. So 4, 5. So it'd be 5 and 5. Do you get the idea? So when we are doing the reflection, stretches and everything is same, perfect. But it is coming on this side instead of going there. That means it is also reflected on y-axis. So we can write the equation of g of x as equals to minus square root of minus 4. And since the point has now been 5, 5, it will be x minus 5 plus 5. Does make sense to you? Correct? So what I've done here is actually find the equation of g of x. Right? What I will suggest is, so that's a question for you, which is question 7. You sketch a graph and then find the answer. Clear? So for the time being, I'm giving you a hint how to do it. So that is your line x equals to 4, it gets reflected. So all of the stretches and compressions remain same. The only thing is it has an additional reflection on the y-axis, and that is the point where it actually finally starts from. And therefore, that becomes your starting point. So once you do that, then also state domain and range. Is that clear? So that will make it more interesting. So I hope you understand and appreciate what we have done in this video. Feel free to write a comment, share your views, and all the best. Thank you.